So we're going to be installing Ubuntu Server into a virtual environment. Currently, I run Xen servers. Right here, you can see 8 of my Xen servers. Each one of these is a physical bare metal device that has Xen 7 installed on it. I then use a product called Xen Orchestra to manage those images, and this gives you the ability to install devices pretty simply and maintain. Instead of maintaining 100 physical devices, you're maintaining 8 physical devices, or however many physical devices you need to host your 100 images. And there's some benefits for backups, replication, shared resources like iSCSI drives, also being able to migrate images from one bare metal device to another bare metal device. So I choose VMware, but this demonstration should work on if you want to install this on a PC. There's also some virtualization software for your desktop. I recommend VirtualBox. That's a wonderful application. It runs in Linux, it runs in Windows, and I believe it even runs in Mac. And if you go down that path, this will work just the same, because the terminology should be one-to-one. You shouldn't have to go looking for information on this. But so to get started, the first thing you need to do is go grab the image. All Ubuntu images are found on Ubuntu's website. So you can go to Ubuntu /downloads, ubuntu.com/downloads, and that's going to bring up your downloads. We're going to be installing server and not the desktop. And just to be clear, in Linux, the difference between server and desktop, it's not like they have completely different development paths like they do in Windows. They're basically the same thing. The difference is that with desktop, they're installing all of the user interface GUI on top of the server, but they're doing it in a way that's, different permission sets, different directory structures, and that's more amenable to the user environment. Server is just bare server. You can actually install GUIs on. If you want to just take the server and install your own GUI, there's a lot of people that do that. Probably not with Ubuntu, but most of those guys end up being Arch users. So when you click on Ubuntu Server, what you're going to see is you're given two servers to download. 1610 is their. It's not, well, I guess it is. No, it's not rolling. They're releasing 1610. So 2016 October they released 1610. And 1604.1 was released in April of 2016. It's pretty simple to understand their release schedule. If you're interested, there is a wiki.ubuntu.com, and that actually breaks down how the releases are going. And so their release schedules, it's the same for desktop and server. You can come in here and see all the different releases and all the different end of lives. And remember, if you do install Ubuntu in 1610, its EOL comes a lot quicker than even, I think it EOLs out, let's see here, 1610 EOLs in July 2017. So it's going to EOL out before even 1404 or any of the LTS kernels. So that's gonna require you to do release upgrades, and there's nothing wrong with those. I've done those and been very successful in doing release upgrades with Ubuntu. But there are times where certain applications, especially if you're going to be installing a server and you're going to be installing items from source, they're not going to upgrade well. So my recommendation is to try and stay with the LTS kernels, and that way you make your decision. Okay, I got 6 years to decide how to upgrade this, and that gives you plenty of time. So, that's once again just my opinion, and I think it's it served me well so far in managing hundreds of images, and I think it's something that you should keep in mind as you're moving forward. Downloading the actual LTS kernel. This should take about 6 minutes, so we're going to skip forward. All right, the download has completed, so let's go to our file manager. In this case, I'm running KDE Neon. There's a video on YouTube of me switching to that from Mate. And in KDE, we use Dolphin. So I have a ISO FTP folder where I drop my ISOs in so that I can go and grab those from my Xen servers. So I simply I've downloaded this to my home directory download files, and I have the ISO directory opened up, and I just drag and drop, and I'm going to copy here. And now this is going to take some time because this is actually a remote location, and even though I have a 100 meg link, getting over there, sometimes that time frame takes a lot longer than it should. So it's running, and I will come back to you once it's done. All right, so 16.04.1 server is now transferred to the ISO directory for my Xen servers. So let's get started. So in Xen Orchestrator and in your Orchestra or Xen in your desktop emulator, whether you're using VirtualBox or VMware, whatever you're using, I do recommend VirtualBox or bare metal install. You're going to then take and add a new VM. Or put the disk into your CD-ROM or the USB disk into your server. So at this point, I get to, because I'm running Linux or Xen, I'm going to need to select which version of Ubuntu I'm going to be installing. And in this case, I know what this device is going to be. So I need to have 2 virtual CPUs and 4 gigs of RAM. And that's the requirement of the software I'm going to be installing. Now, in a virtual environment, this is not fixed. You can come back at any time and increase the CPUs and increase the RAM, and your Linux server image will then be able to just take that once you do a reboot, and now you have 4 CPUs and 8 gigs of RAM. It's very simple. That's one of the reasons why I mainly don't do bare metal installs of servers anymore, unless it's something that's maybe real-time media required. But when it comes to hosting an image in a virtual environment, it just makes the deployment of the image so much simpler. Now we have to select the ISO. Now, I just copied the ISO up, and as you can see, it's now here in my drop-down. Now, I configured my environment to allow me to make it this simple. This is something that I've done as part of my daily workflow. So setting up the ISO image in there was pretty simple. Now, you can do Pixie boots. I am personally not opposed to Pixie. I just don't do enough. We're not a hosting company that's doing hundreds of installs a month or even a week or a day in some cases. We're not a DigitalOcean. We are a telecom company that service telecom images of our own and software on top of that. So I don't need Pixie boot. For this tutorial, though, or for this methodology, it's not even worth going into. If this is going to be a image on a private network and public network, then you can add that here. Now, once again, the benefit of a virtual server environment is that you can take that server environment and put VLANs into it. So in my case, I have the ability to add this to a public or private or DMZ or uplink, different networks that are required on my part. So at this point, I'm set to the public. Now you get to select your disk. In this case, I have local storage and I have Xen storage. So I have a terabyte iSCSI LUN that is built for building images on. You're going to want to name. So in this, we're just going to call this 1604 LTS root. So when I look at this, this is going to be a 1604 LTS root disk. I'm going to leave the description as created by XO, because then that way I know that I created with Xen Orchestra, not with the Xen client that runs in Windows. The size is literally what it is. So in this case, you get to size, do I want a kilobit drive, a megabit drive, or gigabit? So I'm going to go gig. Now, my base installs, I want to keep them as small as possible. So I usually go about 16 gigs. I can always add in a second drive and FS tab, add that drive into my boot process so that it shows up as a local folder. And this prevents me from building drives too big. So when I do migrations or backups, it's much easier just to get the backup of the operating system. So let's say I want to migrate this disk to another server, and I have a log disk that's 100 gigs. For the backup purposes, I could drop that log disk, just move the 16, recreate a log disk on the other side, and map it. And now I didn't have to migrate 116 gigs worth of data across a network, which in my case could be between Fargo and Bismarck, which even though it's a giggy uplink, the transfer can actually go very slow because of latency. So those are the kind of things that you kind of keep in mind when you're building virtual environments. On your server, when you're doing bare metal installs, you're going to get a drive, and it's going to be whatever you are. All we're doing right now is creating a virtual physical drive for Ubuntu server to identify. So in the advanced settings, there are just a few items to point out. And when you're creating a virtual environment, boot VM after creation. So once I hit create, it's going to boot up and I'm going to see the image. You get to set your memory. Now you can choose between dynamic or static. Mine set it dynamic because this is just a image. I do set my primary production servers to static, so I don't ever have a memory collusion where I then start writing off to some swap within the virtual environment. This actually means I'm going to write off to swap on the server in some cases if I set too low, but it's better than actually having your virtual server go into swap. I'd rather have my image go into swap and figure out how to fix that problem. CPU weight is always for me set at the default of 256 unless it's going to be a production server, and then I do set it down accordingly. I can actually multiply the VMs, so if I wanted to create multiple instances of this build, I can, and I have done that in the past where I wanted to spin up 10 servers instantly, and this will build 10 servers instantly, and it actually works pretty good. So in summary, this little summary window here just kind of tells you got 2 CPUs, 4 gigs of RAM, 1 hard drive that's 16 gigs as we set up here, and 2 network interfaces, one on my private, one on my public. I'm going to be loading from an ISO. Now, if you guys are wondering, and I didn't cover this, but an ISO is just a disk image. So originally ISOs, and right now it's just the terminology that's used is you would take a disk and you would create an image of that disk, and then an image of that disk could be loaded into a virtual environment or copied to a server, or you can mount that image on Linux and turn it into a virtual DVD. So if you wanted to, bring software over, and so ISOs have been around for a long time, but all an ISO really is an archive of a bootable image. And so what we're saying is whether you're using a USB, a DVD, or you're installing it via virtual disk over ISO, is you're just accessing that archive to the install with the bootable references in it. So let's go ahead and start this. And there we go. So my image is now started. All right, so now that we've started, you'll see that Ubuntu comes up. You saw that there was an initial window that kind of gave you some options, but it says, okay, what language do you want to run? Obviously, I'm going to select English. So after we've selected English, you're presented with some options for installation. So install Ubuntu server, install mass region controller, mass rack controller, etc. You can check the disk, you can test the memory if you have a physical device. You can then just say, hey, boot from first hard disk. I don't want to actually boot from this. And you can also rescue a broken system. Now, mass is metal as a service. But back to the simple installation. So we're going to select install Ubuntu server. And the first thing it's going to do is going to run through the basic install. Once again, I have to select English, United States, detect your keyboard. I'm going to say no because I know I'm US and I'm done. It initially goes through and loads all the basic components. Now, I am running this in my data center. So I have a 20 gig uplink to the internet. So things might run a little bit faster as I go out to the public internet and grab information. But for you, that's if you're requiring a internet connection, it's best that when you plug the server in, you boot it up, that you actually have a physical internet connection. And I usually run that as a DMZ, so that when I boot my server up, it comes in a network that gets a DHCP IP address, and all it can do is go out and grab its updates before anyone can get access to it, before it can go out and talk to anyone other than the public internet. All it's going to do is, it's just for doing this initial install. So ETH1 was on my private network, and so it's going to go out and grab the IP address for IP4 and then check to see if there's IP6. And once it's done that, all right, so now that we actually have a DHCP IP from my private network, we're going to then set up the host name. In the past, people used to name their servers after comic book heroes or Greek gods or Star Wars themes or whatever it was, and I never appreciated that, and quite frankly, it's quite irritating. Because you look at a bunch of servers, you don't know what they are. Great. So all you've done is confused your admin staff, because if someone's hacking the box, they could care less what it's named. They just want to get into it. And once they're into it, they figure out what it's doing and they go from there. So what I've done, or what I've been doing in my network, is I just name things by, what is this box service? So if someone is able to get into my network and see my host names, yeah, they're going to see a dev box, or they're going to see a ops box, or they're going to see a prod box. And so you got development, operations, and productions. And there's other names we put out there for, you could prefix every Windows box on your network was easily hacked dash, so that way easily hacked dash of what you need to watch to make sure you're not getting hacked. But in this case, this is going to be a dev box, and at that point, now that I have the dev box identified, I need to go through and identify what this box actually does. So this one happens, I'm going to be installing Nginx on. This is going to be the first one that is going to be installed for development. This may, at the point that it becomes a production image, then I will change the name of the host to ops or production, depending on where, if it's out in the public, it's going to be production. If it's in the private cloud, it's going to be operations. But it's going to be defined at that point. So at this point, it's development. So I've set the name. That's going to be what you see when you console into it. Once I get the server up, I'll change the name in my virtual environment to reflect it. All right. So now that we've gotten to this point, we can now type in our full name. I do recommend that you don't use generic names like test user or sysadmin or whatever it is. There's already a root account that anyone can get access to via SU or sudo. So what you should do at this point is type in an actual user. So you want it to use your username, and you want to be clear that this user has access. So you don't give everyone access to this, you do. So if they don't need it, they don't get it. And in fact, in most cases, I only have 3 or 4 users have access to a server, and they can only access it through their username and password. And in some cases, they can only access the server if they have the right certificate from the computer they're accessing it to. And that keeps us from having unwanted users getting access to production level images. So this is part of why Linux is so great. It's the authentication and authorization and directory structure and how permissions are granted to users. And don't bucket. Use it. Don't try and change it to be more like something else. Use the permission structures that are within Linux. So create your full name, and you're going to type that in. And in most cases, I do the first name plus the first letter of the last name. That keeps it clear when you're looking in folders and you're trying to delete users and you're trying to understand things. You know who they are. It's not going to be Mike. In my company, there's only one Mike, but in a lot of companies out there, there's 3 or 4 Mikes, and in some cases, they all work in IT. So keep that clear when you're doing usernames. You want to have unique names. All right. Use a strong password. Even in your initial setup, don't don't use password, because there's guys that have built Unix or Ubuntu images, dropped them on the internet, typed in, test user with test password 1234, and by the time they got around to logging into their computer, it's already been compromised. All right, so I've typed in my proper username and passwords, and we are now looking at the configuration for an encrypted directory or not. So you have an option at this point to encrypt your home directory. In most cases, I don't encrypt my home directories, and there's some good reasons why I don't, because I'm not actually putting anything in those home directories at all that's worth encrypting, and it's an overhead that doesn't need to be there. Now, I could encrypt those home directories, but it's not necessary. There are reasons to do that, and that's mainly specific to the design that you're going to be deploying. So if your server is a secure server that needs encrypted home directories, then do it. But if you don't, why take on the overhead? Why take on the requirement of encrypting a home directory that doesn't need to be encrypted? So I always, in this case, I select no, I do not want to encrypt my home directory. So it's going to try to determine your current location. So my time zone, yes, is the central time zone, and so I'm just going to select Chicago. So now we come to a LVM, or use entire disk, or encrypt entire disk. And once again, this all comes down to the environment you're running in. So as a server, if you use your entire disk and you don't ever plan on increasing the data size, so for example, if you have a RAID controller and you have X amount of drives on that RAID controller and it's never going to increase, then use entire disk. If you have a RAID controller and you're populating 4 drives and you have a total of 25 you can install, but you're going to start out with 4 and a RAID 5, and as you can afford it, add more, and then go with LVM because you can expand your disk space. And actually, it doesn't hurt to go with LVM. Now, I do want to point out that you can LVM across non-rated disks. I don't recommend that for servers, and if you're doing that, you're just setting yourself up for complete and total failure. Because if you lose one disk, you lose them all. So just remember that LVM should exist within inside of a RAID or inside of some kind of container of disks that are redundant and backed up so that you don't lose your data. Then you can also encrypt your entire disk with LVM. And once again, that comes down to, if you want an encrypted disk, then encrypt your disk, by all means. It makes perfect sense. And there are certain servers I have that have encrypted disks because I don't want to worry about people getting access to private data. But in the case of this server, or this development server I'm running in Nginx, it's not necessary. And it's an overhead that I don't need to do. So in this case, I'm going to select the LVM. Now, if you remember when I built the image, I built a 16 gig image running on a iSCSI LUNT. I can go and increase that from 16 gigs to 32 gigs, come into the LVM and increase the size of the disk, and I don't have to install another disk and attach it as well. So I always, when I'm doing a virtual environment, I'm assuming the disk I have, or the image that I'm already putting on an LVM image, that image can expand. And so in this case, I'm going to install this as an LVM. So it's recognized my 16 gig. It's going to show up however it's going to show up. In this case, it shows up as 17.2. It's going to ask me, do I want to write the changes? You're going to click yes. I mean, most of these questions at this point, if you really care, yeah, you can go and, modify them or view them. But if you're just doing a base server installation, remember you've installed it as LVM and you can go increase it in the future. So in this case, it's gone ahead and created the LVM. It's created the different partitions within that LVM to support Ubuntu server, and you're ready to go. This process takes however long this process takes, depending on the speed of your disks and the speed of your hardware. All right, so now we're going to be asked to enter the proxy. In this case, there is no proxy. It's just going through a firewall via Masquerade. if this server is going to be something you just install and forget, and you don't care, and if that's the case, then you probably don't care if it goes down, then install security updates automatically, because you're not going to actually be watching it, and you're not going to care about it. So let it install its automatic updates. Updates automatically. If this is going to be an image or a server that you want to manage yourself, and you want to make sure is updated, then then do no automatic updates. And also some other options out there. Landscape from Ubuntu is quite nice, and if you're interested in doing that, it is a commercial product, but for managing servers, it really is quite nice. So you can actually use Landscape as a way to manage updates and manage your actual physical device, or virtual device as well. So your virtual images and your bare metal servers can all be managed by Landscape. All right, I'm going to go with no automatic updates. I never do updates automatically. All right, so now this is just the base install. I do not recommend that you select anything other than OpenSSH server. The reason for OpenSSH server is so that you can now SSH into this device automatically. Otherwise, you would have to get in through a console or through a terminal session directly connected to the server and actually install that device. Or install OpenSSH server. So by doing this, it skips a step of having to do that in the beginning. All right, you click enter, and it's going to go retrieve all your packages from your ISO and from the internet if necessary, and away it goes. All right, now it's going to give you the option of installing your GRUB bootloader, and my recommendation is if you're installing a server, the answer is yes. All right, the installation is complete. It's time to remove your ISO, which in my case has already been done, as you can see up here, because once it gets done installing, it automatically does it in Zen, and you hit enter. The server is actually built, it's running, it's waiting for my login. And Ubuntu installed. Now, the first thing you're going to see here is I have 108 packages, can be upgraded, 52 updates, and our security updates. Keep track of that. If you log into your server and you're seeing that you need to do updates, if you're not going to go and do the research on the updates, you need to make sure that you're applying the updates that are ready for your distribution in Ubuntu. Don't wait until someone says, oh, by the way, did you hear about that great vulnerability out there? Because it's already been out for a long time. And a lot of times the kernels are being patched before everyone's being notified. So make sure you're keeping up with your updates. So this is a fresh install, so those updates haven't been applied yet. First thing I usually do is I go out and I find out what my IP address is. So ifconfig will tell you the IP address that you have in your DHCP server. So now that I know that, I don't have to spend any more time in this, but because I'm running a virtual, I want to install my tools. All right, so you have your guest tools. In this case, I've just installed my guest tools, and now I can come over here and connect to that ISO and install the Linux tools so that everything now works with my virtual environment. So the way that you do that in Linux in the server, because you don't actually have a GUI to go browse to a disk, is you're going to want to mount that ISO to a local folder. So first thing you want to do is create a folder. Now in this case, because I'm running as my user, I have to sudo to go to privilege mode. So sudo, you want to make a directory, and I do make it under temp because I want it to go away at some point, especially on a reboot. So I do a make directory under temp under cd-rom. It's going to require your password, and now I've made that directory under cd-rom. Okay, so let's go ahead and mount that disk. So you're going to go to super user mode. You're going to do mount dev disk by ID, and then you're going to type in the ATA. Okay, so now that's going to mount that disk, and you want to go to your temp cd-rom. Now that's the directory you created. So we're going to mount that disk to that cd-rom. Now you can go ahead and type in ls/temp cd-rom, and you're going to see that there's now a directory structure that you can go into. Our file exists under Linux. Okay, so the best way to do that is just do sudo /temp /cd-rom /linux, and you're going to see in here that there's a install.sh. Just type in install.sh. All right, it's going to ask you, are you sure you want to do this? You say yes, and now you have your Zen guest tools installed on this image. So as a fresh image, it's ready to go. So we determined in the beginning that the IP address is 10.10.1.74. So now I can bring up my connection tier and go to 10.74. And because my username locally is the same username we're running on that server, it's going to allow me access. Now that we're into the server dev and GenX01, we can do our updates. So you're going to want to do sudo apt update, and that's going to go out to the repos. It's going to pull down all the updates that need to be, packages that need to be updated. Now you're going to want to do the sudo apt upgrade. It's going to run all your upgrades. It's going to, you can type in a -f if you want to force it, but it's going to upgrade all the packages that, since the time that you released it to the time that you're actually installing it, that they got updated in the background. Now you can now run those updates separately. All right, so we now have a complete install of Ubuntu. As you can see, all the updates that were applied, and we are now ready to move on to the next phase of our project, and that is installing whatever it is we imagine to install on top of Ubuntu to do whatever task it is we needed to do. And that's where we start. One of my recommendations, though, and this is something I do typically because I run a virtual environment, I now have a fresh install. It does require a reboot, so I usually do a reboot of the image. Now you can take a snapshot live, but sometimes it doesn't get everything perfectly, especially if you have traffic in the background. So what I've done constantly is I'll stop the image, take my snapshot, start the image, and as you can see, I have a fresh snapshot, so I can always export the snapshot, create a VM from this snapshot, or trash it. But this gives me a fresh install of Ubuntu. You can also even create a template out of this snapshot, so instead of having to go through this whole process in the future of installing, since you have this base install, you can just take the snapshot and run it. So 16 gig disk. I have two physical networks with an IP address of 10.10.174 my private. The public I haven't set yet, but I'll set a static IP address for that. You have some general 2 processors, 4 gigs of RAM, 2 network interfaces, and 16 gig hard drive. And it's running Ubuntu. And that's about it. That's what we have to show you today. So we'll come back and hopefully do some more videos in the future that kind of take this maybe to the next level.